Here I am going to implement a variational autoencoder using Keras library, and for training the variational autoencoder I am going to use the MNIST dataset. So here we can see that the MNIST dataset is inside the Keras library. So I am loading the MNIST dataset, that is the digit dataset. Once I load the MNIST dataset, I just normalize it by dividing it by 255. I'm setting the number of epochs, the number of iteration through the whole data 100, and the batch size in one single iteration. Not there is difference between epoch and iteration. Epoch is iterating through the whole data, whereas iteration is just one batch. So in each iteration I am passing 100 samples, so that's why I'm setting the batch size 100. Now I want to model variational autoencoder. So this is the simple variational autoencoder model. This is the encoder part. I'm getting the mu, the mean, and the sigma value, and then I'm sampling z value from the mean and the variance, and then I'm giving it to the decoder, and the decoder then give me the output, generated output. So the total loss of this variational autoencoder is consists of two losses. One is the reconstruction loss, and the second one is the KL divergence loss. And then once this is done, we have to train this network, and the training is taking long. So what I did, I just save the parameters. I already trained this network for 100 iterations, and I saved the parameter using this code, and I just want to run the test code, like how it perform on MNIST dataset. So once I run this code, now here we can see that what I did actually, I just I plotted the feature space, the encoder output, and there are 10 digits 0 to 9. So these are the different distributions of the different digits, like this one is 0, maybe this one is 0, this is 1, similarly this one is 9. So the color represent the different distribution of the digits. So here we can see that the distribution are unique, but they are closely related to each other, so interpolation is possible in this case. Now the second step, if we don't pass the input and we just detach the encoder part from the decoder, and we only use the decoder. So what we need to do, we will just sample from that prior distribution, and we will just use a sampled value and put it on the decoder side, and we will see what is happening. So in the next step here, what I did, I just sampled the z values from the prior distribution, and when I pass it through this decoder network, it generates all these digits. So here we can see that different digits are generated without any input. So variational autoencoder has the capability of generating the new samples without any input, because the learning process is based on learning the distribution, the prior distribution, the Gaussian distribution. So we are sampling the z value from their distribution and using those sampled value to generate the new output. So these digits are somewhat similar to what we have trained this network on. So this is 520 8179. So these are like when we are sampling randomly, it will generate the digit based on the distribution. We are like if we sample it near 0, so it will generate the value which looks similar to the 0 value. So it depends from where did we sample those z values.